Okay, let's unpack this.
Let's do it.
So we're doing a deep dive today into something that feels like it's moving really fast, from philosophy almost straight into, well, reality.
Yeah,
This deep hybridization of human and machine intelligence.
absolutely. And for years, we've mostly talked about AI as this kind of advanced tool, like a supercalculator or maybe a helpful assistant.
Right, just something we use.
Exactly. But the sources we're looking at today, they really push for a much bigger shift in thinking, a paradigm shift, really.
Okay. So what's the mission then? What should you, the listener, take away?
Well, the core mission here is to challenge that old view. We need to kind of stop seeing AI as just this external thing that helps us be more efficient.
Like an add-on.
Yeah, precisely. And start recognizing it as a genuine collaborator, something that co-evolves with us.
Co-evolves, okay.
And this collaboration, it's fundamentally blurring the lines, the traditional boundaries around what intelligence is, what knowledge is, even what agency means.
And to really get our heads around that blurring, we need to go back, don't we? Back to the start of the idea.
We do. You have to start with Donna Haraway, back in the 80s. Her idea of the cyborg.
Right, the cyborg. Seems almost sci-fi, but it's foundational here.
It really is the intellectual groundwork for all this modern hybrid AI stuff. Her cyborg wasn't really about, killer robots taking over.
Yeah.
It was about the integrated being, this amalgam of human and machine. And it showed how fast technology was becoming just inseparable from who we are and what we do.
Okay.
But the really crucial bit, and what our sources hammer home, is this idea of ontological boundary blurring.
Okay, wait. Let's just pause there. Ontological boundaries.
Yeah.
That sounds academic. For someone listening, what do we actually mean by that in this context?
Sure. Ontology is basically about the nature of being, of existence. And traditionally, we've kept things in neat boxes, right?
Like, this is natural, that's artificial.
Exactly. Natural human versus artificial machine. Conscious person versus mindless tool. So when we talk about ontological blurring, we mean the very definition of what counts as a thinking, acting thing is dissolving. That line between a biological agent like us and an artificial agent. It's just not clear-cut anymore.
Huh. So the distinction between me sitting here and the complex AI systems I might be interacting with, that line is fading. It implies a real partnership, not just me using a tool.
Precisely. And we're seeing this happen now in what we call collaborative cognitive systems.
Okay.
Here, the machine part isn't just spitting out data for the human. It's actually co-evolving. It adapts its behavior. It learns with the human, often in these shared problem-solving spaces.
So they learn together.
Yeah. And that generates a collective intelligence, a new kind of entity, really, whose abilities are greater than just adding the human and machine parts together.
Wow.
That functional co-evolution, that's the cyborg concept, basically, made real, brought into practice.
Okay. Here's where it gets really interesting for me.
Yeah.
If the cyborg is the big idea, the concept, then building these hybrid AI systems, that's the deliberate construction, the implementation of that idea.
Exactly right. The whole field is basically built on leveraging the different strengths, often opposing strengths, actually, of the human and the machine involved.
So to make it work well, you first have to know what each side is actually good at, like an inventory of skills.
You do, an honest inventory of where each one outperforms the other. We know machines are brilliant at scale and speed, right?
Yeah, processing power.
Operating incredibly fast, handling enormous amounts of data, often messy data, running complex algorithms efficiently, making these actuarial forecasts. They're just amazing at spotting patterns humans would miss.
Okay, hold on. Actuarial forecasts. Most people think insurance, finance.
Yeah.
You can give an example in a hybrid system that's maybe less obvious? Something surprising?
Okay. Think about managing a global supply chain during a hurricane or some other disaster.
Yes.
Total chaos. The machine can process billions of data points almost instantly. Weather models, inventory levels in hundreds of places, truck routes, changing regulations, all of it. And it spits out a highly precise, data-driven forecast for how to best move resources for the next, say, 48 hours.
That's speed and scale.
Yeah.
Impossible for a human.
Undeniable machine superiority in that task.
But that forecast, however good, it still needs a human eye, doesn't it?
Absolutely. Always. Because the human side, we still blow the machines away in these critical, often messy areas, like problem solving when things are completely new.
Stuff the machine hasn't seen before.
Exactly. Creative reasoning, intuition, empathy, and crucially, ethical judgment. understanding context, flexibility. We provide that vital understanding of why one solution might be morally better or just practically better on the ground, even if the algorithm points somewhere else.
So you combine these very different skill sets, and you get these powerful, the sources call them pluralistic frameworks.
Yeah.
It sounds like more than just making a person faster or better at their job. It sounds like it changes how expertise even gets created.
That is the key takeaway. It's deeper than augmentation. Think about medical diagnosis.
Okay.
A hybrid system doesn't just give the doctor data quicker. The machine might spot some tiny pattern in a scan, suggesting a super rare disease that's its scale advantage.
Right.
But the human doctor might realize, okay, but given this patient's specific cultural background or their life situation, the standard treatment plan the AI suggests just won't work for them. That's the human's contextual advantage.
And putting those together gives you a result neither could reach alone.
Exactly. A diagnosis and a workable treatment plan that simply wouldn't exist otherwise.
So this integration, it literally expands what we can know, what we can create, what we can manage.
Yes. And it supports different kind of epistemology, a different way of structuring knowledge itself, which, eventually leads us towards that bigger concept we mentioned, Sophimatics. But we'll get there.
Okay, so let's talk about actually building these things,
Yeah.
the engineering. If we accept that these two agents, human and machine, are truly acting together, designing how they collaborate must be incredibly tricky. The sources talk about dynamic task allocation, deciding who does what when, especially when everything's changing fast.
Yeah, that's a core challenge. These systems can't be rigid. They need constant transparency, mutual understanding. The human has to have some idea how the machine got its answer.
The black box problem.
Right, and the machine needs to be able to register and actually adapt to the human's input, even when it's not easily quantifiable, like feedback based on intuition or ethics.
Which leads right to this key design principle. You absolutely need human intervention sometimes, especially when things are uncertain or ambiguous. You need that override capability.
Totally essential. You need a mechanism for reflection and override built in. So, okay, the machine processes mountains of data, generates a super efficient algorithm output. Let's say the best route for an ambulance.
It passes road on paper.
Right. But the human driver sees, hang on, that route goes through a flash flood zone that the sensors haven't quite picked up yet, or there's a protest blocking the road. Human judgment has to override the automated output.
And that override isn't just a one-off fix, is it? The system learns from that.
It has to. That's the reflective part. The AI learns from the human's contextual, safety-critical feedback. It gets better over time, beyond just optimizing based on raw data.
Okay. So to really model this complicated dance, the data crunching and the human reflection, are there specific, cognitive architectures that try to capture this?
Yeah, there are. And one fascinating one mentioned is Sun's cognitive architecture. It's called Clarion.
Clarion.
It's basically a conceptual framework trying to model how the mind works, memory, the brain, and it uses what they call hybrid reasoning. It specifically tries to replicate that dual nature of how humans think.
Dual nature, meaning?
Meaning it has two parts working together: symbolic reasoning and connectionist reasoning.
Symbolic and connectionist. Okay, break those down. Why both?
Well, think of symbolic reasoning as your explicit knowledge, like textbook learning. It uses abstract symbols, clear rules, logic. It's the part that allows for conscious understanding and explaining why you did something.
So that provides transparency.
Justification.
Exactly. If a system uses symbolic logic, it can say, I recommended X because rule Y applies here.
Got it. And the connectionist side. That sounds more like AI as we usually hear about it.
It is. That's the neural network side. It's more like intuitive learning or muscle memory. Knowledge comes from the gradual tweaking of connections based on tons of experience. Often you can't consciously access how you know something. You just do.
Right, like pattern recognition. It's very fast, very adaptive, great for pattern matching, but it often struggles to explain its reasoning in a way humans easily understand. It just knows.
I see. So Clarion tries to get the best of both. The speed and intuition of the network, plus the transparency and logic of the symbolic part.
That's the goal, to have both working in concert.
Okay, but, wow, if you combine those, you run into a massive philosophical issue, don't you? The sources call it distributed agency.
Yes, that's the crux of it. When a decision or an action isn't just made by the human or just by the machine, but by the interaction between the human's conscious choice and the machine's perhaps intuitive output.
Then who is responsible if something goes wrong?
Exactly. The old ideas of individual accountability just don't fit neatly anymore.
Think about, I don't know, a highly autonomous surgical robot using something like Clarion. If it makes a mistake because of some weird data glitch it encountered and adapted to, is it the surgeon's fault? The programmer's? The AI's fault for learning incorrectly?
That is the huge question society is only just beginning to wrestle with. The complexity means the agent making the decision isn't just one person anymore.
The agent is the whole system, the human-machine team.
Right. And we urgently need new ethical frameworks, maybe even new legal frameworks, to handle situations where actions and consequences are distributed across both biological and artificial intelligence.
That complexity, it really sets the stage perfectly for the next piece. We've talked about the cognitive architecture, the mind of the hybrid system. What about its body? How does this stuff manifest physically?
Yeah, we need to move from just cognitive design like Clarion to the physical side, to embodied AI.
So, robots, physical devices.
Right. Robots and other devices designed to actually interact with us and the world smoothly. This is Haraway's cyborg idea literally taking shape. And the focus shifts really heavily here towards achieving genuine social intelligence, not just task efficiency.
Okay, tell us about MIT's COG robot. That seems like a key example here, looking for that social context.
COG was fascinating. It was designed specifically to look kind of human-like and, more importantly, to learn like a human child develops.
How so?
The goal wasn't just getting it to move its arms right. It was about learning social smarts by interacting directly with people, copying things like following someone's gaze, recognizing faces, basically trying to simulate how humans learn the unwritten rules of social interaction by being in a social environment.
That's really interesting, because the aim isn't just building a better tool anymore, is it? The long game for this kind of AI seems to be genuine interaction, real understanding from the machine.
Yes. They need to grasp the nuances of social situations to be truly effective collaborators, not just efficient task doers or, worse, replacements.
Okay. And this deep integration, whether it's cognitive like Clarion or embodied like COG, has these huge ontological implications we touched on earlier, right?
Yeah.
It goes way beyond efficiency.
It absolutely does. If these systems can co-evolve, learn intuitively, like the connectionist part, and make contextual judgments potentially informed by social learning, we are fundamentally redefining things like subjectivity, personhood even.
We're forced to rethink what even counts as an agent in the world.
We are, completely.
So we've laid out the landscape. We've got distributed agency, blurred ontological lines, the need for new ethics. It sounds like we need some kind of overarching framework to handle all this complexity, the metaphysics, the knowledge questions, the ethics, all at once.
And that's precisely why this concept of Sophimatics was proposed. It's put forward specifically in response to the deep challenges of this emerging hybrid age. It's meant to be a guiding philosophical framework.
Sophimatics. The name sounds like wisdom plus math or structure. How does it actually try to connect philosophy, cognitive science, and computer architecture?
It tries to weave them together by taking what they call a fundamentally participatory and pluralistic stance. Meaning, Sophimatics rejects any simple hierarchy. It's not human boss, machine servant, or vice versa. Instead, it mandates that we have to view human-machine interaction as fundamentally co-creative.
Co-creative. Okay.
It's about intentionally designing technology for mutual enhancement, not just optimizing one side or the other, but building systems where the collaboration itself is the point, leading to something new.
So instead of thinking of AI development as just, a technical problem to solve or maybe even a threat to manage, Sophimatics forces us to treat it as a philosophical and societal project from the get-go.
Exactly right. Its ultimate goal is really twofold. First, to help us better understand intelligence itself, now that we see it's distributed across humans and machines.
Right.
And second, to actively guide how we develop technology, ensuring it genuinely enhances human flourishing within this new, unavoidable context of hybrid reality. It's like the philosophical user manual for the collective cyborg age we're entering.
Wow. Okay, so let's try and wrap this up. What does this all mean? We've gone from Haraway's cyborg concept through the nuts and bolts of cognitive models like Clarion, looked at embodied AI like COG, and landed on this idea of Sophimatics. The big takeaway seems to be we're already operating in these functional, reflective hybrid systems, Humans and machines acting together, constantly learning from each other's strengths in this ongoing loop.
A co-creative loop.
Right. It's definitely not just augmentation anymore. It really is about co-creation, forging entirely new ways of thinking and doing things, new frameworks, like you said.
And that co-creation fundamentally is about expanding what can be known, what can be created, and what can be managed in our world.
Right.
It potentially increases our collective capability exponentially.
Okay.
So, considering that, this radical change to the very nature of intelligence, here's the final thought for you, the listener, to really grapple with. What fundamental shifts do you think we'll see in the actual meaning of human flourishing when intelligence itself is no longer just human, but is, by its very definition, intrinsically hybrid? That's the question we all need to start answering.